Hi, everyone. Welcome to the New York Times R&D team session. We're very excited for this presentation that'll explore the intersection of cutting-edge emerging technologies with the field of journalism. To kick things off, I'd like to introduce you to Justin Lewis. Justin leads strategy within the New York Times R&D team. He researches how emerging technologies like computer vision, natural language processing can be applied in the service of journalism. Justin and team, take it away.
Thanks, Erica. Hi, everyone. Thank you so much for having us today. As Erica said, I'm Justin Lewis, and I lead strategy for the R&D team here at the Times. I'm joined today by Lydia, Shwetanshu, and Tuhin, who are or have conducted research with us in partnership, actually, with the NYC Media Lab, and they'll each speak to their work in just a minute. But I wanted to start by giving a quick introduction to some of the work that R&D does at the Times and what it means to have an R&D team at the Times and some of the principles of how we approach our work. So what is R&D inside of a media company and specifically at the Times? As you can see, our mission is to explore how to use emerging technologies in service of journalism. The service of journalism part, we think of it in sort of two different ways. One side of that is sort of aiding our journalists and the company in reporting and news gathering more efficiently, more robustly, and more accurately. And the other side of that is providing a news report to our readers that is faster, easier to use, more comprehensible, and more accessible. And so to do that, we work with many teams around the company, from the newsroom and also product and technology teams. And really the skill set that we have within the R&D team is a microcosm of the company at large. We have people who have worked as journalists, creative technologists, designers, engineers, strategists, researchers. And we sort of think about the research that we do in 6 broad areas. Today, we're only going to touch on a couple of those, specifically research that we've done through our partnership with the NYC Media Lab. But before we do that, I wanted to quickly give you a little insight into the broad range of emerging technologies that our team researches. So when we look at emerging trends, we try to forecast how those technologies and trends might play out over the next 2 or 3 years. And so right now we're doing that in these broad areas around computer vision, natural language processing, spatial journalism, 3D web technologies, media capture and transmission, and then misinformation and trust. And so, a lot of times we try to connect a big area like natural language processing to a specific story or reader experience. And we try to understand how limited uses of that technology can really help either our journalists or our readers. And so we launch experiments, we launch research to try and figure out how the technologies might be useful. Each of these areas could be their own hour-long presentations, but today we're just going to briefly touch on some of our active research within spatial journalism and natural language processing with some of the researchers that we have with us today. For a little context, first on our NLP work, R&D has developed a tool called Switchboard that uses language models to understand the intent behind reader questions and then connect readers with trusted answers that have been written by and provided by our journalists. So this has been deployed on the FAQ pages of the Times website for coronavirus and the coronavirus vaccine. And it's a great example of how we can take advantage of limited use of language models, for instance, in this case, to sort of understand what a user is asking and then connect them to an answer that comes from a journalist. And Shwetanshu and Tuhin will talk in just a few minutes about some of their research that we hope that down the line could further enhance tools like this. We're also doing research in the spatial journalism space and thinking about how we can create new ways to rapidly develop and share AR journalism. So to get right into that, we have Lydia Jessup, who's going to speak about some of her work in this domain. Lydia, take it away.
Yeah, thanks, Justin. My name is Lydia Jessup. I'm currently a creative technologist on the R&D team at the New York Times. And I participated in the 2020 Spatial Computing for News Challenge with the NYC Media Lab. So I'll share a little bit about my experience with that and also my current work on the R&D team. I participated in this challenge when I was a graduate student at the ITP program at NYU. And I'll talk about the work in a little bit, but I applied with my teammate Rashida and we proposed an augmented reality AR project related to covering political news. We both had backgrounds in public policy and journalism, so we were really interested in bringing all these things together. And now at the Times, my focus is more on the UX and UI experiences of these augmented reality projects, and I'll get more into those in a second too. But Justin, you can go to the next slide, and this shows a little bit more about my the project I worked on at the NYC Media Lab through this challenge. We prototyped a social AR or augmented reality app that was meant to be used while watching political debates. And on the bottom, you can see some of our user testing that we did with real-time debates. The idea was that participants or users of the app could use this during a debate with their friends and kind of track and understand the content of the debate. Sorry if this siren is really loud. I'm just gonna pause for a second. Okay, I think it's gone. And so the goal was really to help participants feel that they're informed on candidates by participating in this app. I think you can go to the next slide. So since then, I've joined full-time working on the augmented reality projects on our stories for news. And here are a few examples. We have worked on like a huge range of effects that you can see on the New York Times Instagram page. So this is only a few. We've worked on, I think, published around 30 so far. On the left, you can see this is an effect about hurdling at the Olympics. So this is using motion capture data. We also, in the second from the left, we did a face filter quiz on testing your knowledge on when you should wear, in what situations you should wear a mask. This one, second from the right, is a story about Nam Wah, which is a restaurant in New York's Chinatown. And this is using a fully immersive photogrammetry model. And then the one on the far right is a data visualization that is using weather data and immerses you in the data from wildfires in California. So this is just to show kind of a huge range of kind of types of AR that we've worked on. And there's a lot more that I definitely recommend you check out if you're interested. Yeah, on the next slide is some additional line of work that we've done for Wirecutter and games. So this is the two on the left is showing a desk and a grill for Wirecutter so that readers can see these products in their space and kind of see the product detail callouts. And then on the right is an AR version of the crosswords game. So it's been really exciting to work on all these because it's a new field. So there's a lot of new and really interesting design, interaction, and technical questions. And again, this is just a very quick look at it. So definitely there's more on the website that you can check out. Yeah, and I'll pass it back to Justin.
Thanks, Lydia. Next up, we have Shwetanshu and Tuhin, who have both been research fellows with us on the R&D team through the NYC Media Lab. Shwetanshu is going to kick things off about his research in the summer, and then Tuhin is going to talk about some of his active research that's underway right now. Both projects are within the domain of natural language processing. So Shwetanshu, take it away.
Thanks, Justin. Hey, everyone. I'm Shwetanshu. I'm a current grad student at the Center for Data Science at NYU. I spent my summer working at the Times, and before the Times, I was doing some research in computational social science and data for good. At the Times, my research focus was in NLP, like Justin discussed. So what we wanted to do was look at the rich comments data, and in particular, look at the problem of reader question modeling. So reader question modeling was a problem where we want to look at all the content that readers are producing in our comment section and identify the different questions that they're posing to us. We're primarily interested in noticing the questions that they have, that we can engage in, that we can have authors and journalists and moderators from the Times section address questions that they have the subscribers have in regarding the article. So like this particular image on the slide here, you can see that Tara Page, the author, has engaged with Todd, who is his regular subscriber at the Times and who's looking at this article on, do you really need do you still need the pulse oximeter? So what we wanted to do was we were interested in getting more engagement, but given that there's so much content coming in from the Times subscriber base, it was really hard to identify all the questions. There's tens of millions of comments that have been posted on our platform since the comments feature was enabled in 2007. And as we speak, thousands of comments are coming in. It's just a matter of processing them to identify which comments have reasonable questions that can be looked at. So to that end, we looked at various NLP classification problems. So using this comments data, we wanted to identify comments that have value to be taken as time picks, reader picks, which are ways to identify the comments and highlight the comments that are useful to the article, that add substance to the author's contributions. And then we wanted to look at things like question quality assessment. So for that, we used the Google Quest data, which has 20 labels per question, giving ideas into giving insights into whether a question has intent, whether it's been well written or not, whether it's looking for a binary answer, whether it's a comparative question, or things like that. We found that the results for this Quest data were not as meaningful to us because a lot of the questions on our platform are rhetorical in nature. So we ended up creating another binary classification model to help identify which questions that we've extracted from the text in the comment section are useful and ones that require factual answers, and we can get back to them in a manner that's enriching not only to the users, but like to other users who come across that post in the platform. Yep, so that was my summer, and I believe Tuhin's working on something interesting at the Times right now. Tuhin?
Thank you, Shwetanshu. So, hi everyone, I'm Tuhin, and I'm a PhD student at Columbia. I'm specializing on natural language processing. So I'm currently working at Times, and I'm also a fall 2021 NYC Media Lab fellow. So my research mostly focuses on techniques to generate text, like it's mostly controllable text generation. And here, particularly in the Times, I'm working on researching NLP techniques to generate question and answer pairs, given a New York Times news article. Next. Yeah, so one of the overarching question is that what is the goal of our project? So what we want to do is we want to generate human-like questions given any New York Times article from our archive of millions of possible articles. And one can wonder what is the possible use of generating such questions. So New York Times already has a tool board called Switchboard, which basically answers questions which people ask. Editors write high quality question and answer pairs in that toolboard. And there is also FAQ tools where people constantly ask important questions, especially in the times of the coronavirus pandemic. This can be really important because people can have different questions regarding regulations or vaccines. We also believe that one of the possible ways which this research could be helpful is in summarizing a news article in the form of representative and important questions. And you can believe that this question generation model can then be used to recommend articles. Say, given a particular article, if I'm generating a question which is representative of the entire article, then I can just use that question to recommend the particular article. For example, if there's a question about which vaccine is the best, then and if I can generate that sort of a question from an article, so then someone can literally search with that question, and then I'll get an article which talks about it. And one of the important things which I definitely want to highlight is that even though generative models have kind of progressed the state of art in research, it's still not at a place where it can directly be deployed in production systems. And especially at a place like Times, where precision and quality is really, really important. We want to encourage human in the loop procedures where a model is definitely going to generate something, but then there's going to be a layer of abstraction in terms of human editors who is going to look through these generated content and then select the better or higher quality content. So the current work that's in progress is that we are training or fine-tuning generative sequence-to-sequence model on a very inquisitive, open-ended question answering benchmarks, which is publicly available. And then once we have trained our models on such benchmarks, what we are doing is we're evaluating on a totally out of domain like area, such as news articles. Next, yeah. So just to give a little idea on how we are doing things. So let's say a sequence-to-sequence model will ideally have an input text as a sequence, and then it's also supposed to generate an output text. So see, here you can see that if I input this passage, all 3 vaccines used in the United States made by Pfizer, Moderna, and Johnson & Johnson, ... If I'm inputting this text, then ideally a question which is written by a human is which vaccine is best. So I want to highlight what our model generated given this particular passage as an input. It says, what is the difference between the 3 vaccines used in the United States? So as you can see that this question is pretty representative of the entire passage which was given as input. And it's also almost like a similar paraphrase of the question which is asked by a human. So through this way, what we are using is we're using generative model to also increase the possible scope of questions which humans could ask. And then, yeah, this basically just improves the coverage in terms of like several other tasks. So yeah, that's something which I'm currently working on, and I'm hoping to make some interesting progress in this area.
Cool. Thanks, Lydia, Shwetanshu, and Tuhin for that quick look at some of our active research through our partnership with the Media Lab. For folks that are interested, we have a lot more information on our website about these interest areas, but also many of the other interest areas that the R&D team is working on. There are a lot of interesting blog posts, videos, et cetera, on that website that we encourage you to look at. Also, if you have questions, ideas, interest in working with us, you can find all of that information on rd.nytimes.com as well. So thanks, Erica, for allowing us to share just a little bit of our work this afternoon. And yeah, thanks, everyone.
Thank you. Thank you, Justin and team. It's always an incredible journey exploring the bounds of computational journalism with you and the New York Times R&D team. All right.